So let's get into today's class. So I did actually listen to some of the older videos. You can hear a little bit when there's people talking in the background. So if there's people talking in the background, it's a little bit tricky to hear what I'm saying with teaching. So, two objects and inclines. Like I said already, the tension portion you have seen last year. All we're doing now is adding this incline to it. It's really nothing that's overly complicated. The only difference is needing to know which direction this moves. So that's going to be the big trick with this, is figuring out direction. Last year, just as a quick recap for this, so last year if I had an object, here's your pulley, there's a rope, it's attached to a box on here, it's pretty easy to determine what direction this is going. Even if there's friction, what direction is this thing going to move? Both are going to fall down. This one's not going to fall down. Yeah, so the pulley is going counterclockwise or anti-clockwise. So depending on what you have, this is pretty easy to figure out direction. When we had the system that looks like this, where there's two objects on a rope, but this time they're both vertically, how could you figure out what direction this is going to go? Yeah, the heavier object goes down, the lighter one goes up. So again, with this, it's really easy to tell direction. However, now with this new one, I've got this object that goes down, and I've got this object that could go down this way. This is a little bit harder to figure out. So yes, 6 is a heavier mass, so maybe that should go down. However, it's on an incline. So only part of the force of gravity causes this to go down the hill. So before we can figure this out, we need to figure out the direction. Because remember our F-net equation, we need to figure out what's positive and what's negative. This one's frictionless, so it doesn't have a huge bearing on what we're doing. However, if there is friction, I need to figure out is friction going this way or is friction going down the incline. So it all depends on what direction this is moving. You can't figure it out at this point. So this is what we first need to figure out. And once we've done that, we're going to solve it like any other tension question you saw last year. So what we need to do is figure out which force is going to win. So first we need to figure out what force is going to cause the pulley to go counterclockwise and which one's going to cause it to go clockwise. So let's start by drawing some free body diagrams. So I've got FG1, I've got tension here. On this object, you've already seen this. So here's FG2. Here's the normal force. And it's frictionless, so those are the only things acting. Oh yeah, and I forgot tension. So are the two tensions equal? That's a good question. Think about what would happen if the tensions were not equal. Either the rope would break, because you've got too much tension pulling on one side, or the rope is going to not be fully stretched out. It's going to be limp. So as opposed to something like this, where the rope is bent, it needs to be pulled straight. Otherwise, there's no tension. Or it's a little bit harder to calculate tension with that. So with this, we need to figure out what force is going to cause this to move counterclockwise. We'll get there, yeah. So looking at this, which of these forces is going to cause the system to move up the incline and down here? What do you think? Yeah, so FG1. Anything else? So yes, the tension here is moving in that direction, but because it's canceled out with the other tension, I'm just going to ignore it for now. Because tension is an internal force. So we're going to ignore tensions for now. Is that one causing it to go up the incline? No, not yet. That's it. So this is the force that is going to move in the counterclockwise direction. What would cause this system to move the other way, counterclockwise? Not all of FG2. Yeah, the parallel component. So if I'm breaking this up, so we've got FG2 perpendiculars here, FG2 parallel. I know it looks like force of gravity 211, but it's FG2 parallel. So yeah, this FG2 that's parallel, this is what is causing our system to move in the other direction. So these two forces are battling it out. Whichever one of these two forces is bigger, that tells you the direction of motion. So before we can make the F-net equation, before we solve for acceleration or the tension, I first need to figure out which one wins. Don't assume, because if you don't do this on the test, you lose marks. I need to see that you do this first. So we can calculate these. FG1 is M1G. So I can calculate that. Mass 1 is 4, so when you do this, you get 39.2 newtons. And FG2 parallel. So we need to look at our right triangle here. And again, so my slope is 30. If I'm trying to figure out which of these are the angle, it's the one beside the perpendicular. So my 30 degrees is down here. If that doesn't make sense, you need to rewatch the video that we did about objects in 2 dimensions. And just remember, the angle that I'm dealing with is always beside the perpendicular component. So this is FG2 times, what do we want? Sine 30. Because the opposite side of this angle is FG2 parallel. Just from SOHCAHTOA. So plugging those numbers in, we get this. Yes, Marwan? Parallel is parallel to the, it's all relative to the surface. So this one is parallel to the surface because it runs in the same motion. This one is perpendicular to the surface because it's at 90 degrees. So just think about 2 parallel lines. If 2 things are parallel, they're in the same motion.
So parallel is basically the y, the axis movement, and this is the y?
No.
Not necessarily?
No, because we're not dealing with x and y. Remember, x or y are horizontal, vertical.
Okay, so parallel is horizontal and perpendicular is vertical, right?
No. No.
So this is how will I know that?
Well, we're no longer, like I said before, we're no longer dealing with x and y. We're no longer dealing with horizontal and vertical because we have an incline.
Forget that. Is it always going to be like moving? Okay.
Direction of motion is parallel. Not in the direction of motion is perpendicular. I think that's more what you're trying to distinguish. You're trying to compare between what you did last year and this year by saying horizontal movement, not vertical is not with the movement. So I think you're just trying to compare that. So parallel just means in the direction of motion for this case. But notice you can't say vertical is in the direction of motion or horizontal is in the direction of motion because here vertical is in the direction of motion. Here, vertical is partially in the direction of motion. So I want you to just throw out of your mind this horizontal, vertical, throw out x and y, because that won't help you here. Always we're talking about, with the inclines, parallel, perpendicular.
The angle, the opposite is always a parallel line.
Yes. Yep. Yep.
But wouldn't that make it not the hypotenuse of the other line?
So here's the hypotenuse. Here's my 30 degrees.
Another triangle.
Yep.
But why isn't that not follow?
Because I'm dealing with the force that's acting here and not just dealing with the incline.
Okay, but if you use the triangle, isn't a parallel for a hypotenuse?
If so, you're saying if I'm doing this big incline, parallel will be the hypotenuse?
No, the main triangle.
This one?
Yes.
Hypotenuse is this one, which is FG.
You draw the lines of the triangle.
And then I drew the parallel component and I drew the perpendicular component.
So it's upside down.
Yeah, and then here's the right angle is up in this corner. But that's a good question because I've got many students who can't draw that triangle in previous years. So what do these two numbers tell us?
You wanted the link for
Okay, so this is my winner. What's moving down? FG1's pointing down, but you mean mass 1 is going down. You mean that the mass 1 is going down. Yeah, because by saying FG1 is going down, that is independent of who's winning. So because this force is winning, that means I now know my direction. This is the direction, meaning this is forces going this way are going to be considered positive. So all my forces that are going down over here or up the incline here are going to be considered positive. Everything else is negative. So we had to first figure this out in order to figure out direction. Now I'm going to solve this exactly like you solved tension questions last year. So this is why I said, this is why I'm not pushing back the dates even though I forgot to post the video yesterday, because I'm essentially doing the exact same thing as yesterday again. So you get to see it anyways. So, now that I've determined this, let's figure out acceleration. And a reminder with this, if I'm looking for acceleration in a tension question, I need to deal with F net for the whole system. If I'm dealing with tension for the system, I need to look at one of the masses, because tension will cancel out. So if I'm solving for A, we first need to make an F net equation for the whole thing. So first we need the positive forces. We've got Fg1 plus this tension here is in the positive direction minus this tension is going in the opposite direction minus Fg2 parallel. And those are all the forces we've got acting. So F net, we looked at the entire system. What are all the forces moving in the direction of motion minus the forces that are opposing that? Notice my two tensions cancel. This is why tension is an internal force, meaning it cancels out of the whole system. We have Fg1, we solved that already. We have Fg2, we solved that already. Now we just need to look for acceleration. So F net, when I'm dealing with this, I need to deal with the total mass, because when I'm dealing with F net, it's specific to what masses are we using. So when I made this equation, which masses did I look at? Yeah, so I looked at both the 4 and I looked at the 6. So I looked at the total, so I need to deal with this total mass. So 4 plus 6 times the acceleration, yeah, that is 10, equals Fg1, which is 39.2, minus Fg2, which we figured out over here, 29.4. And then we solve for acceleration. Sure. Just don't look at the board. You were almost there. What? Oh, good. I'm glad you got the right answer. So this is what you would get for your acceleration. Again, in order to solve for acceleration, I look at F net for the whole system. Questions on this one? Yeah? Because, so it's not because of friction, so that's a good question. Why is the lighter mass going down in this case? And I'll throw it back out to the class. Why is the lighter mass going down and not the heavier mass? What do you think?
Because it's frictionless.
No, not because of tension, not because it's frictionless.
It doesn't have a normal force.
No, it's not because of the normal force or because it doesn't have a normal force.
I think it's easier to put something up on incline rather than straight up and down.
You're sort of indirectly on the right track. So you said it's easier to push something up an incline than it is to pull something straight up. You're on the right track. And why is that the case? It has to do with FG parallel. You're getting warmer. So friction would resist it, but this one says it's frictionless. So it's not due to friction.
Because F net and F equals to be cancelled out, so you're doing the
No, F net isn't canceling out.
So why is the red?
The force normal, no. It doesn't matter with the force normal. So what force is think about this. What force is causing this to go down the incline? No, tension's not going down. FG parallel. Is all of FG pulling it down?
No.
No, only part of it.
Oh,
So the part that is pulling this system clockwise is just half, because sine of 30 is half, is only half of what the total FG is. So in order to make this system move, with this one going down, I need to have at least twice the mass. Meaning, I need to have this force or this mass to be much bigger than the other, because I'm only dealing with part of FG, not all of FG.
and this one is heavier and it's using all of them.
Yeah, whereas this one's being pulled down by all of FG. So I didn't times this by sine something, so therefore that force is going to be bigger. Yeah, yeah. If this mass was 10, when you did this, it would become bigger and it would go down the incline.
So what is actually parallel when equal to FG1, but it's not.
Mm-hmm. Yep. Forces are balanced, so no acceleration. Yep. So that's why this one's a little bit confusing, trying to figure out which mass will move which direction, because you actually need to calculate it. You can no longer just tell based on what the original masses are. That's why I say you have to add this extra step at the beginning. And it's not all for loss, because notice we use those numbers in this equation anyways, so you're not doing empty work. So let's try solving for tension now. So with tension, like we saw, it cancels out when I'm looking at the whole system. So I can't use that. The easier, or not the easy, the only way to do it is to look at just one of the masses. So ignore the other mass and let's just deal with one. There's usually one mass that's easier to deal with. Not always, but sometimes there is. And it's just the forces. If you want to deal with the one that has no angles, that's probably the easier one. Or that has less forces. So I would suggest just dealing with this box. Ignoring everything else, let's just deal with this box here. So if I were to do this, what would become my F-net equation? Yeah. So FG, I'll leave the 1 in there so we remember which one we're dealing with. Minus tension. No. It's the same. So if you solve it for 1, because we're not dealing with all of FG2, and we'd get a different F-net equation for this one. Because over here it's going to be tension minus FG2 parallel. I can show you both if you want, but you'll get the same thing. Just wait. Does the F-net equation work for a single mass?
No. Yes.
You can make a net equation for any object, any combination of objects.
Would it be the net force of the whole thing, or would it be
Well, let's try and calculate this. So if I'm doing mass F-net here, so it's MA, which mass am I dealing with in this case? The 4 kilograms, which is mass 1, equals, I've already figured out FG1, so I'm not going to write that out, minus tension. So we get 4 times the acceleration, 0.98, equals 39.2 minus tension. So if you calculate that, did I do that exact one? Yeah, I did. So I got 35. No, I got 35. I'm pretty sure your numbers are rounded. It should be 35 rounded to, or something rounded down. 35.28. I don't know what you're doing on your calculators, but it's 35.28. So this is the tension for the whole thing. And just to prove it, we can do it for the other one, but they are the same. So if I wanted to look at the second mass, let's try this out. So for the second mass, again, we want bigger force minus the smaller. So bigger one is tension minus FG2 parallel. This time we're dealing with mass 2. So we get this. We've already figured out this one, thankfully. So 29.4. I have M2. This is 6 times 0.98. Goes tension minus 29.4. Exactly 35.28 again.
What? This doesn't make any sense.
Why not? We already talked about why tension has to be the same everywhere on a rope. Are you just trying to waste time now?
No, I'm not wasting time because we didn't take this last year and like last year it was
Yes, and once you go from grade 11 to grade 12, it makes it so much easier now. So tension equals the same anywhere on the rope. Because if at some point you have two different tensions on a rope, your rope's either going to break or it's going to bend. So how is this a trick question? Solve for tension. So in this case, you can see that solving for either one of them, it isn't that difficult. There will be cases where there's going to be multiple forces, including friction, including maybe another mass attached down here, just for fun. And then you get more forces acting on it. So it doesn't matter which one you pick the one that you think is easier. If you happen to pick one that's harder, that's unfortunate for you, but you'll still get the right answer. So whether or not you can determine which one's easier doesn't really matter in the grand scheme of things. And the final answer, yes. I don't want the whole thing.
Whole number?
Whole number or one decimal place doesn't matter. If you give me like, yeah, that's fine. I just don't want if it's a number that's the full calculator screen, don't write the whole thing. Otherwise, I'll get annoyed and I'll start deducting marks. Yeah.
Can you please explain one more time why every parallel? So it's not every parallel is not affecting the tension because it's not pulling it backwards, it's pulling it down.
So it is affecting the tension when you're looking at this object. But FG2 parallel does not affect this object when I'm just looking at the forces in and of itself. So if I look at this, when I'm dealing with the first object, this is all I'm dealing with.
What am I supposed to look here?
Here. Because I'm blocking it.
Okay, so what do you think?
So if I'm dealing with the F-net equation for one box, I'm just dealing with this. The FG2 parallel has nothing to do with this box by itself. So just like when I'm looking at this whole system and I'm trying to figure out what's happening in this whole thing, I don't care what you're doing in your chair right now because you're not a part of the system. So maybe you have an indirect effect on this, but if I'm not looking at you directly, I'm just focusing on this. So same thing when I ignore one of the masses. Yes, this does have an effect on what happens here. That's taken into account with the acceleration. Once I have that, I don't care about the forces here. I can just deal with what's happening here. So this does affect it, but it affects it when we're looking at the whole system, not just the single system. Okay. Yeah. So so if you're dealing with question A, yes, that does affect it. And if you increase this mass, it increases this number.
So every parallel affects it because it's one pulling it backwards.
Yeah.
And every perpendicular does not because it's only like the part of the FG that's only pulling it downwards.
Yes. Yeah. Careful with your terminology downwards. It's putting it into the surface. Yeah.
What would happen if FG parallel and tension were the same?
In this case,
Yes.
so if those are the same, then you'd have a constant velocity, which means F net is 0, which means when you did this calculation, these would be equal as well. So you're never going to have a case where this whole thing is accelerating, but one of the objects isn't. It won't work. Yeah. The tension is always going to be somewhere in between the two opposing forces. Won't be the average, but it's somewhere in the middle. Any other questions with this one? Okay. So let's try one more with an adorable monkey and an even adorabler sheep, because that's adorabler is a word. So let's try this. Same system of what we're doing here, except now we're going to add in friction. So if I were to add in friction, again, the only thing is trying to figure out what direction is it going to point. So we can draw our free body diagrams here. So let's call this FG1, tension, FG2, force normal. We've got tension this way. What direction do you think friction is?
The same extension.
Do you think up the plane or down the plane?
No.
Yeah. Against tension. So
Opposite. Didn't you say last time that it's downward and friction is the opposite? Yeah.
so I've heard up the plane, I've heard down the plane, I heard opposite the motion, which is correct. But the question is, what direction is the motion? Is the sheep going up the incline or is it going down the incline? You don't know. Well, the masses are given there. But you don't know which one's going, which direction they're moving. So this is why, like in the last example, we first need to figure out direction. Then I can apply friction in this case. So I don't know where that is yet. I need to calculate that. So notice here I've written out the strategy for this. This is what I did in the first one. This is what you need to do for all of them. First, we need to figure out what's the winning force. So in this case, let's break this up. So FG2, let's split this up. How do I want to do it? I'm going to do it this way this time. Because it doesn't matter. So FG2 parallel. If you did it the other way, you're going to get the same numbers. If it mattered how you wrote in the forces, then it'd be really tough. Okay, so let's figure out what force is acting. Let's do it this way. Let's say what's the force clockwise? What's the force counterclockwise? So what is causing this pulley to move clockwise? Clockwise, yeah. So we ignore tension. Just to mess with you, because I love messing with you. Yeah, so it's FG2 parallel. That's the entire reason why I keep switching it, so you get used to two of them.
Why isn't it just close one?
Because I want to know which forces are causing it to go clockwise, which ones are causing it to go counterclockwise. Yep. We did force 1 and force 2, but is force 1 going clockwise or counterclockwise? There you go. So I'm trying to establish you need to know the difference between those. True, but this tells me exactly what I need to know about your situation. It's okay, Marwan just asked that question like 20 seconds ago. Counterclockwise. Clockwise, counterclockwise. I'm going to hold my tongue because there are many things I could say to respond to that. Do I need to pull out the marks books? Okay, anyways, so let's calculate these. And then we can figure out which is bigger. I feel like part of my job as a teacher is to lower people's egos in this class. That's like part of the thing. So whenever someone who's like, I'm way above everyone else, I feel like it's my job to pull down your ego. So if you don't insult someone else in my class, I'm not going to insult you. But if you feel like you need to put others down to make yourself feel better, I'll bring you down.
What's your point, Dennis? That's on YouTube, by the way, yeah?
Yes, it is on YouTube, and I'll stand by that. I don't care if people know that.
Okay. I don't like people knowing the other ones.
I didn't say what your mark is.
No.
And I also didn't say who it was that was talking. Notice that? I'm smart about this. I'm covering my basis. This is dangerous having me teach something that's online.
I'm gonna report that.
Go for it.
I'm gonna make all this big account to like report you
And then it's just gonna take 2 minutes and making you accountable.
Exactly. You forget I still have power over your marks right now, Marwan. It is. So let's calculate these. So FG2 parallel, we can solve that. FG1, we can solve that just like we did before. So with this, again, you're dealing with your triangle. We need to figure this out. Remember, again, the angle here that you're given for the slope is always beside the perpendicular component. So here's the perpendicular. It goes here. So when we're dealing with this, we've got M2G, again, sine 40. Opposite, because we want the opposite side. Yeah. I cannot, because I'm recording with it. Sorry. If you're dealing with the perpendicular component, then you can use cos. So calculating this, what do we get? We're dealing with 28, right? Yep. Okay. So this is equal to 176.4 newtons. That's a terrible looking 4. Force of gravity 2 times sine 40. I got a comeback for you now, Marwan. What you said is also on record. You said it's on record that I said that I have power over your marks. It's also on record that you threatened to take down my entire YouTube channel. It just took me a while to come up with a comeback. That's why I repeated it.
Mr. Brown just said
Yeah.
I have 2 questions.
Yeah.
First question is, when you were drawing the free body diagram in the beginning, does it matter if since we don't know which force is winning, does it matter the length of the line?
No. So that's a good question. So you asked if do the lengths of the lines matter in this case? So when you draw it, I'm not going to mark specifically the length of lines. So once you've determined which force wins, don't go back and change the length of the lines, because that's just going to be a waste of time. I don't want you to do that. Just approximate it like this, like I did, because notice here maybe I've got FG1 is larger than tension, but I don't know if it is. So I'm not going to mark the length of the lines. Don't worry about that.
Second question,
Yeah.
do I have to write M2, like when I'm solving it, do I have to write mass 2 kind of just write mass?
Oh, you mean here? Do you have to write M2? It's easier, not easier. It is better for you to write it out so that if you want to look back at your answers and see if you made a mistake, it's better to write out the 2 here. So just for your clarification, you can see that it's mass 2. Do you need to put it? No, I'm not going to mark you wrong if you don't. However, it's really easy to make a mistake when you go from here to plugging in the numbers if you forget to include the 2 on there. So it's more a matter of like making sure that you don't make mistakes, that you put those subscripts. Then we can simply do this. M1 times G, you know the numbers for those. That gives you, there you go, 235.2. So now we are, what do we got? We got, it's going counterclockwise.
no, clockwise.
Counterclockwise.
Oh, my bad.
So this is the direction of motion. So in this case, it does happen to go the other direction again. That will not always be the case.
So this means it's go.
I'm always confused with winning and losing food. I always get confusion when I'm trying to winning.
Like you're confused on which ones are the winning and losing?
For example, I've been to the next step and so
Yeah. Okay, so once we get to the F-net equation, you're confused which is positive and which is negative? Okay, we'll get to that. I'll explain that.
Doesn't that mean that the friction force is going with the tension?
Yeah, we'll get there. I haven't put that up yet, but we'll get to that. So once we have figured out direction, because we've got the friction, we can now include that in this situation. So yes, if I'm looking at the sheep, now which direction am I going to put the friction? Am I going to put it up the incline or down the incline? It's going down. It's resisting the motion. So this will be my force of friction, is down this way. Again, don't worry so much about the length of the arrows. You just need to know that it's pointing in this direction. No, the two lines to say that those are equal. No, I don't need you to show in here which ones are equal. Like even though I know Fn is going to be equal to Fg perpendicular, I don't need you to write that. Yep, that's why I'm saying this year I'm not deducting marks for that. Yeah, so force of friction is down the incline because I know the sheep has going up.
So if SG2 was bigger, was the friction force going to be with the tension force?
Yeah, so if this system was moving the other way, so if the sheep was going down and the monkey up, friction would be up the incline. So whatever direction the sheep's going, friction points the other way.
So like the friction force doesn't always have to be opposite to the motion.
It always does. What direction is the sheep going? Up. Yeah, we just said that this sheep is going up the incline because it's moving counterclockwise.
Where?
Sheep's going up, monkey's going down. Okay, so now we're dealing with figuring things out. We haven't even started with the acceleration yet. So to get A, we need to make an F-net equation. And which mass am I going to look at in order to calculate acceleration? Both mass. I need to look at both. If I want acceleration, whole system. If it helps, you can think of solving for acceleration, you need all the masses. AA. Acceleration, all the masses. So let's look at what is positive and what is negative. So the last time I went through and just said, these are all positive, minus these are all negative. Let's try a different strategy with this. I'm always showing you different ones so that you can see a different strategy and hopefully you pick up on one that you like better. So in this case, let's just work our way through the whole thing and figure out if something's positive or negative. So FG1, is this positive or negative? Positive, it's going with the motion. So FG1 is positive. Tension, positive or negative? Negative. This is going opposite direction. Yeah, it's just because you weren't looking what I'm doing. Okay, this tension. This one's positive. Force of friction. And FG2 parallel. Negative. It's going down the incline. I know that one's confusing because it's not directly in line with the sheep, but don't forget it. So is FG2 perpendicular causing motion? No. So FG2, we split it up, yeah, into the two parts. So this is my overall equation. Tensions cancel, I don't need to worry about that. From there, we now need to solve what this is. From here, it's pretty straightforward. You're just plugging numbers in and solving it. So F net, mass total times acceleration, equals FG1. So we have the number for that. I'm not going to replace it. Force of friction. So by you calling out my name multiple times while I'm in the middle of talking doesn't help anyone to pay attention. So minus force of friction. We need the equation for force of friction. So I'm going to deal with that. Force of friction equals mu Fn. Which which mass is this friction applying to? The sheet. So what is Fn in this case? It's the perpendicular component. Last year, the normal force was always mg. This year, it's not. So this is equal to mu times Fg perpendicular. And to be specific, Fg2 perpendicular. There's a reason why I put this up here, so I have extra space to write it. For Fg2 perpendicular, this is equal to the hypotenuse, Fg, times cos 40, because it's adjacent. So this is Fg cos 40, and Fg is M2, I forgot 2 there, M2G cos 40. Do you need to show all these steps when you write this on a test? No. I'm showing you it here so you can see everything as I'm writing it out. But this is where I get this equation from. So it's mu times Fn. Fn is now no longer equal to Fg because we're not on a horizontal plane. We're on an incline. So it's equal to a portion of Fg2, not all of it. So I can plug that in here. Cos 40 minus Fg2 parallel. I think we solved for that already, right? Yeah. So I'll leave it as is. Now it's Fg 2311. Yes. Yeah. I just explained that, but you probably were on your phone. So, why did I not say Fn is equal to Fg2? Yeah?
Because the force that puts the opposite direction, force normal is the force gravity.
Yeah, so if you're wanting to balance out forces, you need to look at what's pointing in the opposite direction. Is Fg2 pointing in the opposite direction of Fn? No. So therefore, those two cannot oppose each other. Part of Fg2 is opposing normal force. It's the perpendicular component. So you're just dealing with that portion of it. Yeah? Where'd the 40 come from? The angle. Yeah, I'm just seeing if there's more questions. Which one? This one? Oh, this is mass total. So it's the combination of both. Mass total, not tension. Yeah. So now we have all the numbers for this. For the sake of time, I'm not going to plug in all the numbers, but you have all of this. You just need to solve for what acceleration is, which is yeah. Yeah. You have all these numbers. I'm just not going to write it all out. By this point, this should be the easy part, hopefully. Plugging in the numbers into your calculator is the easy part. No. No, no. Am I going to what, sorry? Am I going to give you hardy ones? Well, I could add extra masses onto here if I wanted to. Extra masses. I could have 2 sheep attached by ropes together on the incline. And then, like, you know the game with the monkeys? Just think about this. If I make harder questions than this, that makes this question seem easy. It's all relative. So before I answer more questions, let's finish off this. Was it already with your class that if I'm having to call out students for not paying attention or for talking, then it's the entire world hears it? Did I say that to your class? Okay. You can't hear me? I was just saying that if you are talking and I have to call you out for talking, it's on YouTube.
That's another class is gonna shut up.
That's gonna be like 2 hours, and they're gonna fill up.
We're only at 52 minutes long, so I'm sure they'll be fine. Yeah. But by the time we skip through all the parts where I have to tell people to not talk, or talking about the evidence that's going to be uploaded on YouTube, and all of this stuff, I'm sure it cuts down a little bit on the time. Heck no, I'm not going to edit this. That would take way too long.
Yeah, it does upload like 2 minutes.
No, right after this, I upload it straight from here, and others can sort it out. This is the consequence of not doing a flipped classroom.
Software.
Yeah, are you missing Pre-Calc 12 yet with all the nice videos that are short and explained nicely and oh. Okay. So we're not done this question yet. If I'm solving for tension, what strategy am I going to use in this case? Pick one of the objects. Which one looks like the easier one? The elephant. It even says monkey on here. Okay, so let's deal with the monkey. So if I'm going to deal with this one has less forces, so it's just easier to deal with, and we don't have to deal with an angle, so why not? So for this, let's make an F-net equation. So this is going to equal, the bigger force minus the smaller force. We know the numbers for this, M1A equals FG1, which we've already solved for. So I'll leave it as this, minus tension. Rearrange this, or you can plug in numbers at this point. Doesn't matter. But you get tension is, when I got 223. But if you got 222, I would still consider that right. Any questions about the tension portion of this? The tension is the easy part. Okay, so before I completely lose your attention, what time do we got? 27, okay. So before I lose you guys here, let's talk about the general strategy with this, because this is a lot, and depending on what kind of masses you've got, I can give you this situation where instead of this monkey being hanging straight down, I can make a double-sided incline where they're both on inclines on either side, and you have to calculate that. Like I said, I could add more masses. So I could make a few things trickier with this to try and figure out an overall system for this. But there are a few things that are always going to be the same, and that's your strategy. So what is the very first thing I did in this question? Finding winning force even before I did that. That's the second step. Free body diagrams. When in doubt, draw the free body diagrams. Draw your forces. That's going to make your life a lot easier. Then, what is the winning force? Why do I need to find the winning force? To figure out the direction of friction, yeah. So once I've got the winning force, that tells me the overall direction. Yeah, and it tells us the overall direction with the F net. And because I know direction, friction opposes that direction. So any case I've got friction, it's going to point the opposite direction. What was the next thing after we figured out direction? Solve for acceleration using F net. F net of which object? Everything. So all the force or all the masses make an F net equation for everything to solve for acceleration. Then to get tension, what did I do? F net for one object, and then that's the last step. So that strategy is going to be the exact same no matter the tension question. Every single time. So that's why it's summarized here in the notes. I added in an extra step here just before the winning forces. I put draw the free body diagrams because it makes it more difficult if you don't do that. So if you want to add up here 0.5 free body diagram, you could add that here. Ali's not even looking and he knows what the answer is. Yeah.
If you give the question with two objects, putting on something on incline, and if you have to find the forces, do we add the forces of the two objects on the incline?
Oh, you're asking, like if I've add another mass here, and I want to figure out the winning force and the losing force? Yeah. So what you'd have to do is you need to look at all the forces acting in that direction. So I'd have the force of gravity of this object and the force of gravity of the other object. So you'd have, for clockwise, it'd be FG2 parallel plus FG3 parallel. Yeah, you'd have multiple things there. Okay, I'm going to finish off the video with this.